So here, this is 126. And we're going to do C construction assembly, and then I've got a few demos, and I will do the flare-on we talked about before tonight by 8:30, if not earlier. Even if there's a lot of people with questions, I'll cut them off at 8:30 so we have a half hour to do the flare-on, because that's interesting, but that's extra credit and in Zoom, and it won't be publicly viewable until the contest is over, which is about another month. But I would like to cover the next two I've solved. I haven't solved the 5th level yet, but I might cover what part I got through it one of these days. But I'm having too much other work going on. I may get no further than I am. Anyway, so let's talk about C construction assembly, which is here. And, all right. And so I'd like to try to do this one live. Now, when I tried before, it failed. I'm just going to see if the EHSC switches change it. I'm afraid the C compiler might have changed something. So I'm just trying to compile a simple program here. So what you do, you click the, I don't think I can get the start button visible on Twitch, but I click start, and then you scroll down to the Visual Studio part. Or maybe this part will be visible. Okay, after you click start, you have to go to Visual Studio, the folder. And in here are the command prompts that do things like we need. And I want to make 32-bit code, so I go to x86 native tools. You have to open this command prompt, not a normal command prompt, or things won't work. Now I can go to the folder where I put my file, which is PE, and in here I've got hello.cpp, and I compiled it. Now I'm going to remove the results of compiling it, which are the exe and the obj, the object file. Right, so now I've got is the CPP, and I can type that. Type is what there was around before Notepad. There. So all this thing does is print hello and nothing else. It's like the simplest program you could have. So I'm going to compile it with the EHSC switch. I don't remember what those do, but that's the way I did it for a while, and I hope it'll give me more normal results. So it compiles and creates a file called hello.exe, which just, oh, I didn't put the / deliberately. Maybe I did it by accident. Hello, all right. There, now it prints hello. So that's good. And what we want to do is look and see how that compiled. And we could do it in Ollie, but I'm going to do it in IDA. Just another way to do the same thing, really. I just want to see the source code, so I'm going to do new and hello.exe and let it analyze with the default settings. And there it goes. And when it loads at public start, but this start function does not contain the code that prints hello. It contains a bunch of junk.
I have a question.
Yeah.
Sometimes they load the file in the debugger. Sometimes they load the code into 400,000. Sometimes they load it at 100,000.
Yes. Code all wants to be at 400,000, but if you have address space layout randomization turned on, it will randomly load it at random location. That's why I use set deal characteristics to turn that off first.
But in Alibaba, when I try to set it into turn off the ASLR, and then but then it's still loaded up into 100,000.
Oh no, I'll try it. I'll show you how to prevent that. No, if you turn off the ASLR, then it will stop doing that. Anyway, all this code here, I think, has got nothing to do with the code the developer wrote. This is all the Windows code to set up the environment. To find the code that you need, you got to go to strings. And it might be one of these tabs, but if it isn't, you can get there with view, open subview, strings, which can be a little clumsy. There's a shortcut for it, which is, I think, Shift F12. There, strings. Shift F12 will do it. That will open a strings tab here. And now I can see strings, including hello, right there at the top. And if I double click the hello, of course, I'll go to the code the developer wrote. Now what I actually go to is the text storage of the word hello. This is the bytes of hello stored. But if I go to the cross-reference and point to it, then up comes the code that printed it. And if I double click it, then it will show me the code that prints hello. And again, I observed that what I wanted to show you is not easy to see anymore. It pushes offset hello and then calls. I wanted to show you a call with several parameters, but there's only one parameter in this, so we're not going to see much. So let me go to my slides and see what I was looking for here. I wanted to do this. I wanted to print a couple parameters and then hello. So let me do that. All right. let's get rid of IDA, and let's go back. Don't save the database. I haven't done any analysis of any importance on it. And let me upgrade that program to have a couple parameters. That's all that was wrong. So I'm going to notepad hello.cpp. All right, and in here I'm going to print, let me just do exactly what I put in the slides, which is %d, %s, 2, and hello. Okay, so print %d, %s, all right, up, %s, \n, quote, and then I'm going to print 2, and then the string hello. I'm going to do it this way. Instead of literally putting hello in the format string, I'm going to have a format string with a string format and print hello there, and put 2 in there before it. So now I have 2 arguments. I have 3 arguments really. The format string, 2, and hello, all to go to the printf statement. So I'll save this with Control S and close it with Alt Fx, and then delete the old stuff. Not sure if I have to. I think it'll automatically overwrite, but I don't feel like being untidy. And now I'm going to compile it, and I think just a plain CL will work fine. Default compiler this thing. Okay, it turns into hello. If I do hello.exe, it prints 2 and hello. So let's look at this one in IDA Pro.
Does the debugger work?
Yes, Ghidra would give you very similar results.
But it seems like it's not.
Ghidra, I don't know about the debugger. I've never used it. There's a Ghidra debugger, but I've never used it. I've only used it as a disassembler.
It seems a lot of setup.
It seems to require a lot of setup. Yeah, I'm not surprised. Ghidra gets pretty complicated. Anyway, so here we are. It's the same old issue. I can't see the good stuff until I go to strings. So it's Shift F12. Brings me to strings, and right there at the top is hello, and there's the format string. So I double click this, and I end up at the storage of hello, and there's the storage of the format string. So I double click the cross-reference address, and now I'm here, and now I can see what I came here to see, which is it pushes hello on the stack, then it pushes 2, then it pushes the format string, and then it calls this subroutine, which must lead to print. So the point is there are 3 parameters, and it pushes them on the stack in reverse order, which is what I wanted to show you. Now, they're just seeing how to spot a function call in assembler. That's what you'll see. A few pushes in reverse order and then a call. Now, let's do what you were doing. Let's see how it loads in Ollie, because that's a good thing to demonstrate. So let's load up Ollie debug. All right. And let's load that program, which is going to be CPE. Hello, all right. So when I load it, there it is. And when I view the memory, memory map, okay, here's hello, and it is loaded at F80000, a crazy random address, not 400,000. So that means the addresses I see here will not match the addresses I see in IDA, because IDA always shows it at the 400,000 because it doesn't actually run it. It just shows you where it would load if it loaded in like the default situation. Do I have to use Flare VM? No, you never have to use Flare VM. You can just use the VM I handed out. The projects that mention Flare VM, you can just ignore that and use the Windows 10 that you got from me with tools. It's better. All right, so let's fix that. All you do is go to the program here, and I should be able to, I can do C, tools, set dill characteristics. There it is, -D on hello.exe. There. And by the way, this is something I kind of wanted to show you anyway. You can see that in CFF Explorer. If you go to C, PE, and you look at an executable, if you right-click and open with CFF Explorer, you can check that here. It's in one of these headers. I found it. NT header, file header there. Characteristics. It says click here. When you click there, here are the characteristics, and here you see it's executable and relocatable. The location info is not stripped, but it's relocatable is an option here, which should be turned off. 32-bit. Well, I'm not seeing it. I thought I saw relocatable in here. Local numbers, aggressively trim, system file. Well, all right, I'm not seeing it. I think I saw it there before, but maybe after you removed it, it doesn't show there. Let me just try this again. I'm going to put that flag back and see if I can see it in, wait, I don't know what's happening here. I just want this to go away. Get lost, go away. What is this question? Save changes. No, don't save changes. All right. Therefore, you can actually do this. You can change this flag in the in that GUI program. But anyway, let me go +D to put the flag back in. And now let's see if I can spot it in CFF Explorer. I think it was the fourth header. All right. Click here. And nope. Well, I guess I'm wrong. I thought I saw it before, but maybe I'm only going to see it for 64-bit code or something like that. It may be the 32-bit code. I don't know. Anyway, let's see if that got rid of it. Now I'm beginning to see what you're saying. Maybe, let me go back and supposedly strip it. Maybe this stripping process is not working on this native 32-bit code. Although it should. So now let's try Ollie again. All right, so let's see. Ollie debug. And open that thing, hello.exe, and view the memory. And there it is. It loads at 400,000. So it works. I can't see it in CFF Explorer like I thought I could, but all you need to do is set deal characteristics -D. That will take that flag off.
I did the same thing, but I think it's probably fair on it's just something to the file, and it's stopped that file, that tool from working.
Well, yeah, you show me whatever you did. You said it didn't work for this. It's always worked for me. So, but I wasn't. Anyway, so that's good. That's a good thing to talk about. And so let's just go on. So the point here was just to see a function call. And of course, someone's asked if there's 3 pushes before a call, and that's not necessarily true at all. It'll be however many parameters there are. Some functions have 1 parameter, some have 2, some have more. All right. So let me find my slides. All right, so that's what a function call looks like. And we talked about how to find it, strings and xref, disassembly. So you see push, 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 call. That's the pattern. You'll see some pushes and then a call. And all that is the function call, which is what leads to format string vulnerabilities. When you call a function, it just assumes when you get there that the parameters are on the stack. If you didn't put them on the stack, it will just use whatever random junk it finds there as the parameters, assuming they were put there. This is a common situation. Computers have no memory. They have no context. When it does the call, it doesn't in any way know whether you actually did these pushes or not. It just starts the program, looks on the stack, and processes whatever it finds there. That's the problem with low-level languages like assembler and C. C is technically a higher-level language, but it's very close to the assembly, which is why it has so many security problems, because it doesn't add any extra features to prevent you from making that kind of mistake. All right, so global variables are stored outside all functions, typically in the data section, and therefore you can reach them from any function in the program. Local variables are defined in a program and they only exist while that function is running, so they're stored on the stack, and when the function returns, the stack memory is released to be reused, so they only exist temporarily. So you can see them, and here's a program that will demonstrate that, so let me make this one. I think I'll just reference it here. I don't think it's worth making these live. So if you make this one, let me make this as big as it's going to be. All right, so here, a global variable is defined up here outside main, and here's a local variable defined inside main. So when you compile it and take it apart in IDA Pro, you will see here is that format string, %D, and that's local. That just lives on the stack. Here is pushing ECX, and here's pushing, all right, here's the global variable going on the stack. I'm going to print global and local. The global variable has this address, 41B1000. So that's in another data segment, not the code segment. That's the data stored globally. And the local variable is going to be this, just pushing a value of a register, or something like this, EBP plus var4, something calculated from EBP or ESP. That's just a value on the stack. So it's only going to have meaning when this function is running, and when you do the return, it will be thrown away. So that's the difference between global and local variables. And you've got arithmetic operations. So if you define some variables and then do addition, subtraction, multiplication, and division, and print all that out, you can see all those variables going by here. They're all local. So it's going to set 3 and 6. So var 8 is I, var 4 is 6. And here it's going to do some calculations. So you see it doesn't add and subtract, it does an integer multiplication. And here it's going to do a floating point division. So it uses these XMM floating point registers, which we almost never use in the kind of work we're doing here, but you can use them. There are a whole number of registers that don't appear by default in OLLI just for floating point math. And the main use of that is for like 3D rotation in games and stuff. It's not usually important for the kind of logic that we're doing in malware. Then there's an if. So I equals 3. If I is greater than 0, print this, else print that. So I have an if statement. So that's going to look like this. You load something into 3 into something and 0 into something. So in the stack, it stores the 3 and the 0. Then it does a jump less than or equal. So it compares the number it just loaded to 0. And if it's less than or equal to 0, then it goes here and prints it is not positive. Otherwise, it prints it's positive. So this is what an if looks like. You have a jump, then you have the 2 arrows to 2 different things. That's the if. All right. And loops. So I make a loop for I. This will go 100 times, print something. And so you got 4 components. You initialize it at 0. Then you compare it, is I less than 0, like an if. Then you have an execution of a function. And then you have increment, I++. So there's 4 things in this loop, which is why these high-level languages are favored. With one simple statement, you can write a lot of assembly code. And here's all that assembly code. This is the initialization starting in at 0. This is the increment, adding 1 to it. This is the comparison. I'm comparing it to 64 hex, which is 100. And then it decides whether it's greater than or equal to that. And then it either executes this or it goes somewhere else to say it's all over. So there's quite a lot of assembly code in those couple lines of C. And here's arrays. You can define an array with a series of numbers, and then you can go in here and define a local array, again, and copy. You can define both. This is a global array, and this is a local array. And you fill them with data. So when you look in the assembly code, you initialize it here, you increment it there. Wait a minute. Yep, here's assignment to the element B. This is going to assign to something on the stack. It's going to have a variable and do a complicated calculation to where to put it on the stack. Base pointer plus 4 times an index counter of which element of the array it is, plus I'm not quite sure where var 14 is here, but anyway, that must be the base of the array. Yeah, the base of the array is EBP plus var 14. So it's 14 bytes down the stack is usually what that means. And then this is the counter that counts up by 4 because you write 32 bits at a time in 32-bit code like this. So that's filling the local variable, and here's filling the global variable with an explicit address, and again, jumping forward by 4 bytes at a time to load it with the data. So more stuff that you should be able to recognize in assembler. So there's the summary. To find the code, in IDA, you go to strings, then find a string you know that you've seen, and then cross-reference to get to the code the developer wrote. In a function call, you push arguments on the stack in reverse order, and then there's call. Global variables are in memory, available for all functions, and they'll show with an address like 405,000 or something like that. Local is on the stack. It'll show as a calculated value, EBP plus number, or ESP minus a number, to be in the stack frame. And arithmetic usually work with variables in the registers, and then you just do add, subtract, division, and so on, and the results go back into variables. They go into registers, and then you put them in variables. Branching, you compare, and then do a conditional jump, and you'll see 2 arrows coming out. So that's all. Let's try a Kahoot, which I should have the Kahoots, and I do. This is 126, chapter 6. So should be in this mess. There it is, chapter, is that 5? It is. That's rude. All right, somehow I don't have it. I'll find it this way. 126. It is chapter 6, right? Yes, it's chapter 6. All right. All right, chapter 6 is somewhere in my mess. It doesn't sort them in order, but it's pretty close to being in order. I think they're just by creation date, not by the actual alphabetical order, but anyway. Now that they're making people pay the money, maybe they'll improve their product. It's a pretty good product anyway. Despite minor user interface irritations, it gets the job done pretty well. And they did the right thing. They focused on what the students see. It's not really that important what the teacher sees. Spiders, scorpions, okay, and I guess getting in the Halloween spirit. Creepy emojis. All right. All right, so what kind of variable is stored on the stack? Yep, those are local variables. They only exist while you're running that function, and they're discarded when you leave. All right, what C contract appears as 3 boxes connected by arrows in IDA, like that? All right, that's an if statement. Good. All right, what C contract appears as several pushes followed by a call? Pete says the image of the ant is going to give him nightmares. Yeah, it's good for Halloween, that ant. All right, that's invoking a function. That's how you call a function. All right, and what C construct looks like that? D word followed by a long address. That's a global variable at that address. All right, good. So I got ants. And honey. And root. I think I know who root is. That's from before. All right. So let me stop the recording.